Hello everyone, we're going to talk about the alternating series test now, and one of the things that I want you guys to see about the alternating series test is that there's always going to be some series where the numbers go from positive, negative, positive, negative, positive, negative. There's two criteria that you guys can see here that must be met. If these two conditions are met, then we can say that the series converges. We cannot guarantee whether it's an absolute or conditional convergence without another test, and we'll talk about that in a little bit of time. The one other thing that I want to say about this is that there's a third condition that should be met, and just ensure that the series is actually alternating. There's very rare times where you see something in the series and then you start plugging in, the first term, the second term, the third term, and then depending on what this function is, it actually may keep a sign positive or negative. There's an example that I'm going to show you guys in the next video that is exactly what I'm talking about here, that it looks like it's going to be an alternating series, but it does not, and so we have to do another test on it. But with the conditions that you see here to the left here, these two right here, well, why do these actually have to be met in order for this to actually converge? Well, the first condition says that the previous term has to be greater than the following term. So in this instance, the first term must be greater than the second term, and the third term must be greater than the fourth term. And then the second condition must be met is that the limit as you approach the series has to be equal to 0. And that's true for any series, right, for the nth term test. And so an example that you can show you this is that, let's say that if I do a sub 1, I'm going to get 1, and then I get, so a sub 2 gives me negative 1/9, and then positive 1/8, and then negative 1/7, and so on. As you can see that as we're going further and further to infinity, our numbers are going to get really, really small to the point where they just end up being 0. And so we can say that the series converges. So let's actually look at an example and talk about this. And the one other thing I'll just say really quickly is that if either condition is not met, then the test will be inconclusive. So again, it could be the fact that it's not an alternating series test. So let's look at the very first example here, example number 1, and it says, does the following series converge or diverge? And then we're going to talk about whether it's conditional or absolute as well. So for example number 1, this is an alternating harmonic series. We're very familiar with what a harmonic series is. And so what we're going to end up doing here is we're going to do 1 minus a half plus a third minus 1/4. So our numbers are actually changing, positive, negative, positive, negative. So the first thing that I'm going to do is I want to go ahead and write out the nth term for this. So sigma positive infinity n equals 1. And so I'm going to go ahead and do negative 1 to the nth power. And since I do this, then that's actually going to have me have a negative term for this. So I'm going to go ahead and subtract 1 from it. And that way, when I plug in 1 here, this becomes 0, and so this gives me the 1 power. So then when I plug in 2, I'm going to get negative 1. So if this had been a negative first and then a positive, I would have just left it at negative 1 to the nth power. And then I'm going to go ahead and multiply this by 1 over n, right? So there's our harmonic series. And so the first thing we're going to do here is we're going to find out our two tests. So the first test is the term. Remember, we're just looking at the a sub n, right? So this right here is our a sub n. So we're not looking at the other part of this for a second. So we're just making sure that is the second term, so is a sub n, is that greater than our 1 over n plus 1, right? So we want to know, is this a true statement for all terms? So no matter what it is. And this, you can see, is very easily solvable by just actually cross multiplying. And since n is always positive, right, n is always positive, then I know that this has to always be true, right? I know that n plus 1 must be greater than n. So I now first know that the first condition that was written right here must be true. Okay, so let's look at the second condition. So the second condition says that the limit as n approaches infinity, again, we're just looking at the a sub n now, so we're just looking at this right here, of 1 over n. Well, this is a very easy function to find the limit of. It's bottom heavy. It definitely equals 0, so we're good with this problem. So with that being said, we can now say that this series is actually going to converge. because it has met both criteria of our alternating series test. Now, whether or not it is a absolute versus a conditional actually depends on our A sub n. So what I tell students to look at for this is let's ignore this piece right here, and let's just look at this series as a separate problem. So we're just looking at what A sub n is doing. All right, so we just look at this little piece right here, and we all know that this is actually going to diverge. All right, it's going to diverge, and we know it's going to diverge because you actually see that the word right here. You guys are familiar with this. This is a harmonic series. So since this diverges on its own, but when I start flipping the signs, it's actually going to converge. So we call this a conditional convergent problem. Okay, so hopefully that makes sense to you, and we're going to stop there for this example, and then we're going to come back with a lot of examples for you guys for that. But that's the idea of what the alternating series test is. So I'll see you guys in the next video.